National Electrical Code Section 680.74 addresses the bonding requirements for hydromassage tubs. This section is crucial for ensuring electrical safety around these installations. The specific requirement states that all metal piping systems, metal parts of electrical equipment, and pump motors associated with the hydromassage tub must be bonded together. This bonding is achieved using a copper bonding jumper. The code further specifies the characteristics of this bonding jumper. It must be made of copper and it can be insulated, covered, or bare. However, the most critical aspect of the conductor is that it must be no smaller than 8 AWG solid. The key term here is solid. The code explicitly requires a solid conductor for this application, meaning that a stranded conductor, such as the number 4 stranded wire, is not permissible. The reason for this requirement lies in the need for a reliable and robust connection that can withstand corrosion and maintain its integrity over time. Solid conductors offer a larger contact area at the termination points compared to stranded conductors when considering corrosion. This larger contact area reduces the risk of increased resistance due to corrosion, which could compromise the effectiveness of the bonding. While a number 4 stranded conductor has a larger overall cross-sectional area than an 8 AWG solid conductor, the code prioritizes the reliability and corrosion resistance offered by the solid conductor in this specific application. The intention is to ensure that the bonding connection remains intact and effective, even in the harsh environment often associated with hydromassage tubs where moisture and chemical exposure are common. Now let's delve deeper into why solid conductors are preferred in certain grounding and bonding applications. Solid conductors, due to their single, continuous cross-section, provide a more direct and less impedance path for fault current compared to stranded conductors. This is especially important in grounding and bonding systems, where the primary goal is to provide a low impedance path for fault current to quickly return to the source, facilitating the operation of overcurrent protection devices like circuit breakers or fuses. Stranded conductors, on the other hand, consist of multiple individual strands of wire twisted together. While this construction provides flexibility, it also introduces small air gaps and contact resistance between the individual strands. These factors can slightly increase the overall impedance of the conductor, potentially slowing down the response time of overcurrent protection devices in the event of a fault. In the context of hydromassage tubs, where the presence of water increases the risk of electrical shock, it is paramount to ensure the fastest possible response from the overcurrent protection system. The use of a solid bonding jumper helps minimize impedance and ensures that any fault current is quickly conducted back to the source, tripping the circuit breaker or fuse and interrupting the flow of electricity. Furthermore, solid conductors are less susceptible to corrosion at the individual strand level. In a stranded conductor, moisture and contaminants can penetrate between the strands, leading to corrosion that can degrade the conductivity of the conductor over time. In a solid conductor, the absence of individual strands minimizes the surface area exposed to corrosion, making it more resistant to degradation in harsh environments. This is particularly important in applications like hydromassage tub bonding, where the conductor may be exposed to moisture, chemicals, and other corrosive elements. It's also worth noting that the 8 AWG minimum size requirement is also crucial for ensuring adequate ampacity and mechanical strength. The bonding jumper must be able to safely carry the maximum fault current that could occur in the system without overheating or failing mechanically. An 8 AWG copper conductor provides sufficient ampacity for most residential hydromassage tub installations. Additionally, the solid construction provides greater mechanical strength compared to a smaller stranded conductor, making it less likely to be damaged during installation or service. When installing the bonding jumper, it is essential to follow all applicable code requirements and manufacturer's instructions. The jumper must be securely connected to all metal parts of the hydromassage tub system, including the piping equipment and pump motor. The connections must be made using approved bonding connectors that are listed for the purpose. It is also important to ensure that the bonding jumper is properly protected from physical damage. If the jumper is exposed to abrasion or impact, it could be damaged, compromising its effectiveness. In such cases, the jumper should be routed in a manner that minimizes the risk of damage, or it should be protected by conduit or other suitable means. Regular inspection and maintenance of the bonding system are also essential. Over time, connections can loosen or corrode, reducing the effectiveness of the bonding. It is recommended to periodically inspect the bonding connections and tighten them as necessary. If any signs of corrosion are present, the connections should be cleaned and treated with a corrosion inhibitor. In summary, the National Electrical Code specifically requires a solid 80 AWG copper conductor for bonding hydromassage tub components. This requirement is in place to ensure a reliable, low impedance path for fault current, minimize corrosion, and provide adequate ampacity and mechanical strength. While a stranded conductor may have a larger overall cross-sectional area, it does not offer the same level of reliability and corrosion resistance as a solid conductor in this specific application. Always adhere to the code requirements and manufacturer's instructions when installing and maintaining hydromassage tub bonding systems to ensure electrical safety. Here are some additional considerations for hydromassage tub bonding. Firstly, the bonding conductor should be as short as possible and installed in a direct route. Long bonding conductors can increase impedance and reduce the effectiveness of the bonding system. Secondly, avoid creating loops or bends in the bonding conductor. Sharp bends can create stress points and increase the risk of damage. Thirdly, ensure that the bonding conductor is properly supported and secured. The conductor should not be allowed to hang loosely or be subject to excessive stress. Fourthly, use appropriate bonding connectors that are listed for the specific application. Do not use wire nuts or other general purpose connectors for bonding connections. Fifthly, when connecting the bonding conductor to metal parts, ensure that the surfaces are clean and free of corrosion. Remove any paint, rust, or other contaminants that could impede the flow of current. Sixthly, apply a corrosion inhibitor to the bonding connections to protect them from moisture and chemicals. Seventhly, torque the bonding connectors to the manufacturer's specifications. Over-tightening or under-tightening can damage the connector and compromise the connection. Eighthly, visually inspect the bonding connections after installation to ensure that they are properly made and secure. Ninthly, perform a continuity test to verify that the bonding system is properly connected and that there is a low impedance path between all bonded parts. Tenthly, document the bonding system and keep a record of all inspections and maintenance performed. In addition to the general requirements for hydromassage tub bonding, there may be specific requirements that apply to certain types of installations. For example, if a hydromassage tub is installed in a wet location, such as a bathroom or outdoor area, additional precautions may be necessary to protect the bonding connections from moisture. In such cases, the connections may need to be sealed with a waterproof sealant or protected by an enclosure. It is also important to consider the potential for galvanic corrosion when bonding dissimilar metals. Galvanic corrosion occurs when two different metals are in contact with each other in the presence of an electrolyte, such as water. The more active metal will corrode, while the less active metal will be protected. To prevent galvanic corrosion, it is important to use compatible bonding connectors and to avoid direct contact between dissimilar metals. If direct contact is unavoidable, a dielectric barrier should be installed between the metals to prevent the flow of current. Another important consideration is the grounding of the hydromassage tub equipment. The equipment grounding conductor provides a path for fault current to return to the source in the event of a ground fault. The equipment grounding conductor should be sized in accordance with the National Electrical Code and should be connected to the equipment grounding terminal in the hydromassage tub equipment. The equipment grounding conductor should also be connected to the building's grounding electrode system. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage and provide a low impedance path for fault current. The grounding electrode system should consist of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrode should be installed in accordance with the National Electrical Code. Regular inspection and testing of the grounding system are essential to ensure that it is functioning properly. The grounding system should be tested periodically to verify that it provides a low impedance path for fault current. If the grounding system is found to be defective, it should be repaired or replaced immediately. Finally, it is important to remember that electrical work can be dangerous. Always follow safe work practices and wear appropriate personal protective equipment when working with electricity. If you are not qualified to perform electrical work, hire a licensed electrician. By following these guidelines, you can ensure that your Hydromassage tub is properly bonded and grounded, providing a safe and enjoyable experience. Always consult the latest edition of the National Electrical Code and local codes for specific requirements in your area. It is important to stay up to date with any changes or revisions to the code to ensure that your installations are compliant and safe.